Physics video on the Inmendhams channel. It's a response to Holiday. I'm just not going to do the troll videos on the DraftScience channel. And, there's this backstory here, right? This is just a petty response. If it wasn't for the context of the other arguments, maybe he wouldn't feel the need to have this kind of attitude because somebody's challenging the authorities again. Ooh. It's just psychology all over the place, and so I'll answer some of these criticisms. The biggest criticism comes up, okay, where's all this math? They want a whole bunch of convoluted math. I'm supposed to do all this, create tensors and spandrels, and have all these names for these different kinds of subdivisions of mathematics that they cram into equations, sub-equations that are inside the equation, that are inside the equation. And I don't even know if that's any of that crap is necessary. The whole way they do math is preposterous. They're the same symbols for different things in different circumstances, and it's just crap. And a lot of it, I think it's crap in the way it is constructed. It's not a very logical mathematical mechanism they've created. And as Feynman even points out, one of the biggest shames to physics is here they have this it's a conversation about this fundamental part of physics, which is energy, and they don't even have a consistent way to quantize energy. They don't have a single name for the single quanta of a single, like a Planck constant of energy. They got calories and kelvins and the whole long list of different manifestations of energy, and that's retarded math. It's retarded science, not to standardize some of these basic mechanisms. And once they have established standards, then they don't have to use this convoluted language, because they have things that have been explained rather than things that haven't been. Well, anyway. So, and then the second context I'd give is that when Einstein presented his contention of space dilation, and the original one, which is really simple, just this argument about the speed of light being a constant, which really isn't too scary, right? And the fact that acceleration, inertia, not movement without acceleration, consistent movement, everything that is consistently moving has a consistent frame of reference to physics. So it's only when something's accelerating or changing speed, that their perception of physics may be different, something like that. But I mean, he just said it. It didn't come with a big bucket of math. He just said it as this is a law or a rule. I'm saying that I'm describing the cause of effects. I don't need to have a bunch of math to go with it. Now I can just import math and say, look, well, I'll do it. I'll do a demonstration. But I mean, it's just stupid. It's just a petty complaint. It doesn't have anything to do with the contention I'm making, the simple bullet-pointed contentions, which I will be adding one or two. I want to try to write them more precisely, but it's because it is science. You want to do it. You want to say it right once and not have to re-say it again. Let me reload it so we see any new comments.
So,
Petty man coming soon. There he is, Petty
man.
So,
I've been watching a few of Inmendhams' revolutionary.
Well, a few of them probably wouldn't even be fair, would it? Yeah, really. Not if you're going to sit there and do this kind of a whatever hatchet job on. Make the contention that there's no math presented.
Physics videos, and I watched him essentially dismiss one or two points which were made towards him about the let's call it missing mathematics, and because he has this quote of Richard Feynman in mind, where he glibly states that this shadow model articulate shadow model of forces creating an aggregate push towards the centre of each other, giving rise to an inverse square law, that he outrightly says he's not changing the mathematics. It's just...
Yeah, I'm saying it because it's the truth. I'm not changing the mathematics. So let's just do it one more time real quick. So the idea is that there's a constant pressure of stuff, photons, cosmic rays, whatever you want to call them. So you have, just imagine, even pressure all the way around everything. And so when two bodies come in contact with each other, or in vicinity of each other, realistic vicinity, you could say a star is doing the same exact thing, but it's just, obviously when you look up at the sky, those little points of light are so tiny that the effect they're going to have on you is such a tiny percentage of the overall effect on you that the shadow's not going to mean anything. But anyway, clearly so just think of the pressure's always being applied. The pressure's always being applied, so it's always pushing on everything. So when two bodies become close, are in vicinity of each other, it becomes quite obvious that the pressure from this direction is now no longer hitting this object. So it's just getting pressure from these other directions. And that's the nature of gravity. Now Einstein's curvature, is this dimpling of space thing, and space gets smaller and a little item sits in here, and you have this curve, right? This centric curve funneling idea. You've seen the images, right? If you haven't seen the Einstein dimpled space thing, okay, you're probably not up to this conversation at all and should definitely keep your mouth shut. So anyway, what you basically end up with is, in Einstein's image, is this kind of a funnely thing. Okay, I mean, it's deep, it's harsh in the middle, and it gradually goes up to the edges. Now, he doesn't give you an explanation for that tension in the fabric, right? You can imagine, like if the fabric has no tension in it, you'd put something in, and it'd be almost like a straight line. The sides would be vertical, the thing would be sitting at the bottom, so whatever hoop you use to contain the weight, it would just go right through, like a fishnet or something. Something with very little tension is going to have just straight lines on either side. It's going to be a standard cone with straight lines. So here you've been given an example from Einstein of a tense fabric. No explanation of where the tension came from, no explanation of why the tension exists or how tense the tension is or any of that stuff. In essence, no explanation beyond, it does it. It will reflect mass accurately. Just a statement. Well, why does it reflect mass accurately? Why? Why is an important question here. And this explanation explains it. So all I'm doing basically is saying, look, you take Einstein's funnel, Einstein's, there's a word for those, cone. So you take Einstein's cone, and you just put it where it belongs, okay? You put it sideways from between the two objects. And you just cone right up to the edges here, right? So what you're basically seeing between the two items, as you can understand, is that the density and mass is going to be greatest, well, first, in most bodies we're talking about in the center, because that's what gravity is doing to them. It keeps compressing everything into the center. But regardless, you can understand that the density is likely to be greater at these greater radii, or diameters. So that would be creating this curvature in the cone. So when I first drew it, I just drew a triangle, a shadow. But like I said, the math is going to tell you the r squared, inverse square rule is going to tell you that it's going to be this proportional thing. It's going to have these curves to the line because the mass is really thin here, so some of the rays are going to get through here, and none of theoretically the least of the rays will get through here, and everywhere else there'll be more. That's really all it's saying. It's saying the least comes through here, and everywhere else there's going to be more rays getting through because the density is going to be thinner. The mass density will be thinner, and it'll create exactly the same thing Einstein created, except it's going to create it coherently, where you can actually understand exactly why it's creating it. So it's a perfectly reasonable explanation, and it fits the math. So I don't have to rewrite the math. Okay, we already have the math. I'm just giving you a more rational explanation for why there's a clear proportionality between the strength of gravity, this curve represents strength of the gravity, and the mass of the object, because the mass is distributed. Yeah, so there's your explanation, blah blah blah. What else do I want to get to? Well, there's stuff I want to get to on acceleration again too, but I think that's enough on that subject, so we'll let him play a little here.
An alternate description of reality consistent with the old paradigm, the old mathematical paradigm. But this is not at all true. Firstly, about the
well, I think I just pointed out that it is true. It's a perfectly consistent. The model perfectly fits. You can perfectly see. Like Feynman even used the words. He actually said these words. You don't need the math if you have a model. Okay, he said those words. It might even be in the clip I played. It still might even be on there, but it's in that exact segment where he says those words. You don't need math if you have a model. If you have a scalable model, then you can just scale the model and perform the math with the model. And that's all I'm saying here, is that pretty much we have a scalable model now. You almost don't need the math, because you could visually see the cone, where you could do the minor math of recognizing what you're cutting off of a straight line cone. So this would be a standard formula for distribution based on diameter. So again, they never use diameters. They always use the R squared thing, because that's a volume thing. See, the R squared thing comes out of the fact that, when you make a line, you can make a cube off the angle, and so it's this cube that's the R squared part. It's always this kind of cubing of area. But anyway, I don't want to get into that. But the point is you certainly could have a formula describing this area reduction that takes place from a perfect cone to a gravitational cone, and I'm sure they've already done that for Einstein's bent space. So I'm sure they already have those formulas. Jeez.
Inverse square law. You understand that at least the simplistic inverse square law is flatly wrong, right?
Well, no, it's not flatly wrong. You're saying it's wrong because Mercury doesn't obediently obey every aspect, because Mercury obviously is being influenced by things different than other planets. It's the one closest to the Sun. If the Sun has any irregularity, there's nothing in this law, right? We called it a law, this inverse square law. There's nothing in this law that says gravity is always consistently generated. Okay, especially in giant molten hydrogen blobs, there's no indication that the distribution of the gravity is going to be consistent, or that also it has magnetism, which is involved also. So there's no, and it's also producing a ton of energy at an inconsistent, not a perfectly consistent rate, sunspots and such. So obviously Mercury, traveling pretty close to the frickin' Sun, going pretty frickin' fast, is probably not going to obey every single rule like Earth or other planets, because the influences are entirely different.
That's what the general theory of relativity tells us. The complexity of...
Well, I'm sorry, the general theory of relativity doesn't have shit to do with Mercury, so fuck you, you're an idiot.
General relativity is a mathematical theory which describes geodesics on curved surfaces as the shortest paths between two places.
Yeah, right. So what he's talking about is light diffraction, because light tends to go in straight lines, right? And so there's a reason when it doesn't go in a straight line. And so in cosmology, they have observed this phenomenon where there's a star, there's a dense object, and then there's the observer here, and the light essentially, well, that part doesn't make too much sense, but okay, it goes here right near the surface and then bends to the observer. Okay, so this is the common lensing effect. Obviously you can see the fact that this would create a lens, you know. Okay, it looks like an eyeball, so yeah, you can do all kinds of metaphoring there. And this is technically the shortest distance for the light, you know, in space-time or whatever you want to call it. I'm going to argue that no, this isn't the shortest distance. The light has been probably red-shifted or whatever it's been done to it in this perversion of its path. And what else would I say? Oh, yeah, and I would say that this is the same effect that happens on the quantum level. This isn't space-time dilation bullshit to mass and all this kind of crap. This is merely bending photons in their path, which means something interacts with the photons, causing a deflection in their appointed rounds. And that could have to do with a lot of the surface. You know, a dense object like a sun would likely have an area of intense material, blah blah blah, in this corona or whatever you might want to call it, and that would certainly be an area where there would be a density of influence. Another way to look at it is, with this cone idea, with this pressure idea, is to recognize that, you know, when you have, let's say you have 1,000 things, 1,000 little balls, and they're in this circle. So this circle is made of 1,000 little balls, let's just say. Well, obviously when I make this circle smaller, it still has 1,000, so they have to be really dense now. They have to be right next to each other. And then when I make it even smaller, they have to be really, really, really close to each other. So this is happening with this pressure wave thing in gravity, is as you get closer and closer to the center, you're compressing the pressure. Essentially, you can understand that you're going to increase the number of impacts. That say if all these things were pushing down and pushing back up, pushing down, pushing back up. I'm using that as an example. I'm not saying this has anything to do with reality. And you were so you were a victim. You were next to it. Obviously, they would push down and go back up very infrequently out here, where it would happen to you all the time in here. You're constantly getting bashed by them because their density is higher. Okay, so obviously when light travels right next to the surface of the sun, when it's trying to go horizontally across the surface of the sun, there's a high density of the pressure particles, the cosmic rays, ultra rays, X-rays, whatever you want, Y rays, whatever you want to call them. And obviously there's going to be a higher likelihood of impact that may obviously knock its path off this and change it to this. And that's basically what's happening, right? I mean, a path that would have taken it this way is now been knocked it this way. And that's pretty easy to intuitively or reasonably say, yeah, that might be okay. That sounds pretty fair to me, cop. So whatever.
On those surfaces is, well, it's extraordinary, and it's somewhere beyond me. In a video I see from the Nottingham University, I forget the name of the 60 symbols. You know, he says graduates in physics, we all grasp special relativity easy enough, but many finish the degree course in physics never really grasping general relativity.
Yeah, well, let's understand that special relativity is already in some trouble, because it's basically making the claim that it's okay to call spontaneous events non-spontaneous events from certain perspectives. And that seems really stupid, right? I mean, you know, get real. Because you don't see it right, it's not spontaneous. So the fact that you see it wrong, and that's what you're doing, you're seeing it wrong, doesn't make it, you know, it's this idea that, say, if you are disproportional to the time of the event starting and the event finishing, okay, so you're an observer. So yeah, if you're closer to the event start, well then obviously light can bounce off, come back in plenty of time for you to see it at the right amount of time. But if you're in a position where you're closer to the finish of the event, then obviously light will come back and forth in so fast that it'll beat the time it takes for the light to go back to the origin and back. So this time, the time from here to here, plus this time, is less than that time. Which I don't know exactly how it could possibly be, but whatever. It's something like this. It's some convoluted mishmash like that, so that you could see the effect before you could see the cause. And somehow that means that that perspective is somehow real. And I'm saying, no, quite obviously that perspective is distorted. And obviously it's distorted by your acceleration, which slowed down your material metabolism, blah, 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 blah. But anyway, don't want to get into that crap here.
It's an area that I spend a lot of time building up to and trying to work up to an understanding of general relativity, and understanding tensor calculus and such. So that there's no shortcuts. If you want,
well, whatever. They're not shortcuts, okay? But there are all kinds of people that have proposed rules. They've stated that this is a rule, okay? Let's see if it's consistent with all the other crap that's going on and is consistent with blah, blah, blah. So they do that all the time. It's just obnoxious of you to say, I'm not allowed to propose a rule.
To do all this hypothesizing, it's really, you risk royally wasting your time without...
Yeah, whatever. You could say that to Einstein then, right? So you're some putz head who would say to Einstein, "Oh, look, Einstein, you don't got nothing, okay? So yeah, you can't make these rules and state them like this is how matter functions, unless you wait 10 or 20 years and do a bunch of research based on it, and then you have a right to say it. I mean, fuck you."
Understanding the mathematics you have to check it against. For example, just on the inverse square law, it's not entirely evident to me that it is equivalent. Can you demonstrate? Do you think Gary can actually demonstrate that, the inverse square law?
Yeah, I just demonstrated the fact that it's quite obvious that it creates the shadows create a cone. The cone is displaced by the density of the mass. So I think I just created the Einstein dimple in space without any fucking time dilation or any other kind of crap. It's exactly the same cone, alright? So, you know, it's the only appropriate response.
Is achievable from this arrangement. It was just a thought. Moreover, this spinning helical swimming fish structure that he envisages for the structure of matter.
Yeah, this idea that matter, okay, is fish that only move the speed of light, that the fish are moving in patterns, not directions, and that it is the pattern that defines matter. Matter is defined by the existence of a pattern. And that's what I'm going to argue about acceleration here. So I might as well do the acceleration bit. Because it's just important to understand that it's the pattern that changes. And once the pattern changes, it has to be, something has to interact with it to change the pattern to some other pattern. So once the fish acquire a pattern, that pattern will be maintained as what we call inertia, or velocity. So I'm giving you an explanation for why things continue to move in space. Has anybody else given you that explanation? I'm telling you why momentum exists. I'm telling you why velocity, inertia exists. Inertia exists because the fish, the matter, okay, has acquired a pattern of movement. They're all moving in let's say, random directions, but they're not random, it's a pattern. But random in terms of no overt function besides keeping them knotted together. And that some proportion, when you create acceleration, when you create a force that pushes them, okay, the push has to go through all of the, vibrates through all of the mechanism that is the school, and a certain number of fish, okay, so originally the fish were just stationary, which meant that, you know, fish, the same number of fish went this way, as went that way, as went that way, as that went that way. So it was entirely neutral in terms of they spent as much time going this way as they did that way, as they did this way, as they did that way. The 6 ways, they went those 6 ways the same amount of time. And that's the key thing here. And then what changes with acceleration is that now more fish, as you put force in this way, you tend to push fish into wider orbits, into going this way more often. Just a little bit. But yeah, a little bit adds up with 1,000 fish or 10 million fish or 10 billion fish. Each fish taking another Planck constant of space-time. Well, I won't use that term because that's just so wrong. But yeah, they're biting off a little bit more space, and so they start migrating in a direction. And they're going to keep doing that. They're going to maintain that new pattern, that new shape to their orbit. They'll keep doing it until something else impacts and knocks them back into neutrality again. And so I'm giving you a perfectly rational explanation for why does the thing keep moving. Well, it keeps moving because the fish keeps eating a little extra space every time it does its dance. It eats a little more space in the direction of the movement. And it won't stop eating that extra space until something forces it to stop. Until something changes the pattern again. The pattern is maintained until something changes it. Yeah, matter has a pattern. Pattern will be maintained until changed, or something like that. Repatterned. Yeah.
It essentially is a particulate explanation of matter, and he has no rigorous mathematics to show how.
No, it's a quantized. Okay? It's not particulate necessarily. I'm not saying what it's made out of. I'm saying it's a discrete bit. I'm giving you the Feynman and the rest of them who says it comes in clumps. Even Bohr, who I think was a stupid cunt, his argument that it's discrete, it comes in clumps. That's why he created the circles that were rigid in atoms, is because it was a clump of energy to force a change in the orbital. A specific amount needed. Which doesn't say much about, look, waves I'll go through a whole thing about waves, but waves are an illusion. Waves are just the period, how often clumps clump. That's all. Waves are a byproduct of the effect of clumping. When you bang on a drum, okay, that's the clump. Alright? The wave comes out, but it was a clump that made it. And waves are made by clumps.
How this structure can generate diffraction patterns, wave patterns. You can say, in the stroke of a pen.
Yeah, so now we're back to the two-slit experiment, which, remember, the entire point of the two-slit experiment is that you have to make these slits really small, okay, so to maximize the amount of interference with surfaces. Alright, because if you make them wider, there will be less interference with the surfaces of the slits. And also, quite obviously, this thing, like I said, if more light comes through straight, it gets brighter and brighter and brighter, and it just masks out any effects of the slit light. So you want to maximize the impacts with the slits and minimize the intensity of the light being forced through, let's say. And so this is just like the camera with the hole in the box thing, the box camera, or whatever the hell they call it. Same kind of physics going on in some respects. It's a little different actually, because there's not as much lensing. I mean, there's not a bending of light in that scenario. There's just a restriction of light, and we can see what the effect of restriction is that you gain a focus, and you gain a reveal of what light really looks like. And if you allow light to be flooded, you won't see those patterns. So the two-slit is basically obliging you to create a camera of the slits. I mean, you're basically taking a picture of the slits. But I won't get into that. Let's do this first.
Oh, it just interferes and makes it, for sure. But that's That's not good enough. That's not going to get him the Nobel Prize.
Yeah, well, that's not the whole story, is it? I wasn't saying I should get the Nobel Prize for my observation that the two-slit experiment, as explained by physicists, is absolutely preposterous, that photons go through both slits and blah, 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 and it's all absolute fucking crack shit insane. Yeah, I wasn't saying I get a Nobel Prize for that. I'm saying that I have now explained phenomenon, substantial phenomenon, and I can tie magnetism to gravity, and I can probably do it to electricity next. And so, I mean, you know, you can, you know, at least get that part right. I'm not claiming the observation that the common interpretation by physicists of the two-slit experiment is stupid, because none of them are saying something rational like, hey, you're shooting light at matter, but matter isn't matter. Matter is made up of energy. That's why the light is acting funny, is because you're shoving it right next to energy. Yeah, they don't say that. They say something idiotic and stupid like photons are reading our minds. And, you know, I think the CIA made photons. Yeah, they're saying crack shit like that. And it is mockable.
So, I would challenge that it doesn't correspond with the predictions of quantum mechanics.
Well, it says you. I'm the one who explained to you fuckwits the Newtonian glass stuff, right? Oh, it's Feynman, it's unexplainable, we don't have any reason, blah, 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 blah. Well, I think the reason is the very structure of atoms, right? Where Bohr pointed out that, you know, you have these standard size things to these orbitals. Well, it seems pretty clear that for glass, you probably have a standard size of the average glass atom, that the atoms are a certain configuration when they're in this configuration or when they're in some other configuration, you know, like this or something. So they have a shape and a position, and just like in magnetism and different things, you can change the shape and position of atoms, even in solid structures, by changing the electrons, change their positions. You might not be changing the nucleuses, but you're changing the orientations of the orbitals. You're changing their blah 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 momentum, whatever, angular momentum. And so what's happening in the glass experiments is clear, in my opinion, is clearly kind of easily to explain, that only a certain number of glass atoms will fit in a certain size container perfectly. And if you have 1/2 of an atom, you've got a problem. So when you have a glass that's thick enough where there's an extra room for 1/2 of an atom, well, then you've got a problem, because now the atoms aren't going to line up the same way. They're going to line up a different way. And so that's creating the difference between the 16% reflection versus the 4% reflection. But I already made videos on this. You just maligned it as if I didn't do it, and as if I didn't explain it. And saying things like, I think it's incompatible, but I won't give you a specific example of how it's incompatible. Well, good. Fuck you.
There are many predictions. There are many.
There's this predictions crap too. This is just such a canard of physicists. This is like one of the things where they just give each other badges for shit. They don't predict crap. They really don't. They've made like 7 predictions, and that's it. Alright? They didn't predict shit. They explained shit. They found some phenomena, and then they said, well, how the hell do we make that make sense with this theory, with this rule? And then they come up with a constant, or they come up with some kind of other crap, and they shove that in there to fix it. Okay? But they didn't predict shit.
Spooky predictions of quantum mechanics.
Yeah, whatever. Those haven't been proven at all, so those aren't going to do you any good as an argument. They haven't proven any of this faster than light anything. They haven't proven any of that shit. So I guess all that spooky action at a distance crap isn't a very good argument for you to be making, since they haven't proven any of that shit.
And beyond the two-slit experiment, have to be explained, correlation of pairs of particles, for instance.
Yeah, I don't even have to do that. I don't have to touch that with a 10 or 50 or 90-foot pole. I don't have to touch shit that hasn't even been proven. Okay, so you can't see a photon. You make up words like pair and spin and wave and tell me it's a real thing. I'm telling you those are words you've used to describe a nuance of phenomenon. I don't have to accept your silly labels. Okay, paired. And maybe it's not paired. You're just going by symptoms. Again, you can't see these things. You have no way to say, well, here's photon A and here's photon B and they're twin brothers. You have no fucking way to do that.
I've not heard him yet, as yet, and I've asked you before, describe how the property of spin arises.
Yeah, the property of spin, even though it's not necessarily has anything to do with spin. So what's the fucking point of telling me I must describe a property of spin? Why? I'm telling you the stuff's moving the speed of light, that it's in arrangements that make that possible. Okay, so if something's moving slower than the speed of light, then the light inside of it must be twisting or spinning. That's my explanation of spin. When I say the word spin, I mean actual fucking spin. I don't mean something else. So until you qualify your claims of spin, you know, are you talking about spin? Are you talking about an energy level? Are you talking about polarization? Are you talking about some other phenomenon? What the fuck does that even mean? Oh, it means it's energy level, right? In electrons? When you're talking about spin?
Within his conception. I suppose that would be simple enough, I guess, you can get the idea of spinning. But there are other particles that have been observed.
Well, all of this has absolutely nothing to do with what I'm claiming, right? I'm talking about this part of physics here. I'm saying that all of that other stuff can be made of photons. And until you show me why it can't be made of photons, you don't have an argument. I'm saying that matter can't be moved a certain way because of the fact that the photons are already moving the speed of light. The fact that there are mechanisms inside of atoms that hold atoms together, I have no obligation to explain all of physics beyond just saying, no, that's just doing the same thing all the other matter is doing, right? Electrons are made out of photons. The photons are moving the speed of light. The electron is not moving the speed of light. The reason is because the photons are moving around each other. So there, I've explained it. I don't have to go any further than that. I'm saying if you want to have a whole list of other eccentric particles, I'm not going to claim there are no such thing. I'm just going to claim that when you make them in an accelerator, it makes it a little bit suspect about whether you're seeing a real particle or you're seeing some broken piece of the car you smashed against the brick wall. I mean, you're just showing up with a bent fender and saying, see, I got a bet, there's a quark. And look, it's a silly quark when it's bent crooked that way, and it's a happy quark when it's bent crooked that way. Yeah, but that's all I'm seeing, so I don't have any obligation to go anywhere near all of your eccentric accelerator-made bullshit. Yeah, I gotta do a phone call. Alright, continuing, I guess. I don't know if there's much other point he's gonna make here. He's just gonna keep bragging for nothing.
It is the quarks are properties of colour, having different colour properties, and that's colour is just a label in this sense.
Yeah, it's another one of these things physicists do just to make it all abstract and nonsensical. That's right. They come up with a stupid label for properties that these things have that has absolutely nothing to do with what it's actually doing. Yes, and it just makes everything all that much more stupid. So, great.
But three distinctive states to describe the structure of a proton. Where does the idea of colour arise in
yeah, I don't bother with it. I'm not bothering with the parts of the atom, okay, right now, that don't have much to do with 99% of the interactions that take place. Okay, 99% of the interactions in the universe take place between electrons and photons. That's the game. Understanding that part of the game is far more interesting, in my opinion, than worrying about the internal structure. But I'm sure the internal structure is elaborate and fancy, but guess what? Most stuff doesn't affect it. It never gets to the core, so to speak. So most of the interactions that atoms are having with the world, they're having with their skin, which is the electrons. Okay, nothing, not too much is hitting them in the heart.
helical fish swimming model. Furthermore, this is born of an entire mathematical theory of symmetry.
Yeah, which I'm not disputing either, okay? So none of that reaction, opposite reaction kind of physics. I mean, that's what they mean by symmetry, generally speaking, is that it's a conservation. Symmetry is really they don't even have they have a perfectly good word, which is conservation, and instead they had to bend it and twist it to turn it into symmetry, and there's just really no point in doing that.
With concepts such as isospin, where the normal idea of a single revolution perhaps possessing an identity symmetry, where you're back to the beginning, in isospin, much like the Mobius strip, you have to kind of make two revolutions to end up back where you are.
Yeah, gee, how interesting, and how I'm not disputing that at all. I'm basically saying that electrons could be whole coils like a spring. There could be a lot of rotation built into them. That could be the explanation. All I'm saying is the basic structure is still made out of photons. It's not made out of something else. There is no other thing anything's made out of. So they're little parts, they're little machines made out of little bits. It's Tinker Toys, okay? It's Lincoln Logs. It's a simple thing, and you can make complex things out of it. It's Lego, goddammit. That's a good example. You can make all kinds of things out of Lego, right? It's just little square things that fit together, moving the speed of light. That's the theory. You're not disputing it with anything. You're just, belching bilge.
Where does this emanate in and these are all experimentally not verified.
Yeah, right. Not verified. That's just so charming. Yeah, you just stepped in that word as soon as you said these are all experimentally. Oh, that's right. These experiments are all kind of crack shit. Even the ones that are 100 fucking years old, they haven't done with any discipline. Right? They haven't done the two-slit experiment by first putting the photographic screen in front of the target, the slits, and saying, let's see what the pattern of light is that we're actually shooting at the slits first. Let's actually see what kind of light we're shooting at it first, before we draw conclusions about the end product.
The sense that has been proven, but their predictions and experimentally verified to the degree of accuracy that the prediction can make.
Yeah, right. Whatever. Yeah, it says you. I don't think any of that shit has happened. None of it.
Or the measurements should make.
Yeah, they haven't even done that, like I said, with 100 fucking year old experiment. They still haven't done any of that shit.
It's definite, but we make measuring instruments, we make predictions of an interaction with our measurement instrument.
No, they draw a bunch of instruments on a piece of paper. They never even do the experiment. They say, well, here's a detector and here's a detector. Well, yeah, we never had that detector in the experiment. The whole thing is just so fucking foul.
Have three identifiable color states, that we have isospin properties.
Well, you're going to keep saying this shit that has absolutely nothing to do with what I'm contending, okay? I'm just contending you're saying these parts exist. I'm saying sure they exist. I'm saying they're made out of photons. The only parts that I really care about, though, is this electron thing, because it's the one doing all the work in the fucking universe, okay? Photons and electrons is like 99% of the ball game.
That we have symmetries. These symmetries have allowed predictions of other particles. There's more.
Well, says you again. So where's your math? Where's your proof of that? Where's that demonstrated? Where's blah, 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 blah? So I could just put you on the table and say, prove it, prove it, prove it.
Is Inmendham aware that there's a whole particle zoo out there, constructible out of
manufactured like cookies in a fucking animal cracker box, okay? Do they really look like zebras? Do they really look like elephants? No, they don't. So I don't think they're I think they're synthesized particles, most of them. I think they might have some connection to some mechanics in the fucking atom, but they're not too related to reality because frankly, they've been created. They've been forced into existence.
You know, so much more than the basic neutron and proton.
And again, what does my theory have to do with any of those particles? I'm conceding the existence of an interior structure that obviously holds things together. I'm not making claims about it beyond the fact that I'm saying it's probably made of photons. And there's lots of ways to make it out of photons. There's lots of mechanisms you could create where you would use up the speed of light in some eccentric motions that tie things together. Okay, it can be done. There's ways of drawing it out as a picture. Again, I could draw the picture of an electron with an open ring, and I could say, see how that could catch on another ring? See how that would have a mechanism that would allow it to be trapped and bound? Yeah, I can draw a picture of it. I'm saying there's pictures you could draw of this stuff. But it has nothing to do with what I'm claiming. The fundament of my claim is the reason why matter can't move the speed of light is because it's already moving the speed of light.
A postulate Inmendham makes is that somehow by increasing velocity, the structure of the matter disintegrates. Well,
I didn't say all matter. What I'm saying is that clearly complex matter, okay, the mechanisms binding our flesh together, the atoms of our flesh, the mechanisms binding some chemistry together are very, very weak. All right, and they're not going to be able to sustain acceleration. Acceleration is going to break them down because the electrons that are holding them together are going to have to start moving in a direction to create the directionality. And once everything starts reorienting, it's going to start losing its cohesion. So that's why I would almost argue that water is kind of, if you push water in space, what happens? The water starts to disassociate. It spreads out. Okay, and eventually, if you try to impart enough acceleration on it, I would argue that the water molecules will individualize.
How does it? This is the problem with Gary's approach. Is it actually, if you pay attention, generates more questions than it answers?
Well, I think that's just a lie. I think clearly on the gravity issue, it answers more questions than it generates, and certainly the magnetism thing, I think I'm really close. With the XY kind of the fact that the radiation flips from one form to another, that the other form is sensitive to, so it's just inverting attraction and repulsion and creating exactly the opposite for the other thing it's in contact with, was just magnifying the effect. So it's doubling. It's a kind of double gravity, which is, I think, a perfectly reasonable explanation. So again, bogus claim. I don't think this creates more questions. It frickin' takes something that is abstract and nonsensical, which is dilation of space and time, and explains to you, well, no, time doesn't change, matter changes. And when the metabolism of the matter, when you put more spaces on a Monopoly board, it doesn't take much brains to figure out. It's going to take you longer to play the game.
Mechanism by which fish have a tendency to swim in a helix, or I've heard him actually say maybe not a helix, just some structure.
Yeah. Well, in my 10 points, 9 points written up now, I'm going to add a couple. I say right there, draft proposal, helix, blah, 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 blah. I'm saying this is one possible explanation. So you didn't even read it, right? I've posted on every fucking video and you didn't even read it?
But why do they, as they slow down, go into the structure and speed up? Why do they stretch out? Well,
this is probably something to do with all that density, right? All the photons that are in the nucleus, the center of an atom, all those protons and neutrons are probably the things that are forcing that confinement. So just like a DNA molecule gets split by certain chemistry, that splits it down the middle, and then the other little piece of chemistry pops on the new pieces. It's like a zipper, and it has a mechanical structure. Well, there's a mechanical structure in the universe. There's a mechanical structure inside atoms, and they conform things. Okay, they're like little machines, simple little machines. They're little nano machines.
Are there really fish swimming in the sea? Is that his idea? I know it's an analogy.
Yeah, so you're just making a pointless idiot. Does Einstein really think the fabric of the universe is made out of fabric? Who does Einstein? What is he, retarded? Yeah, you can just do that. That's really easy to make little mocking statements that say absolutely nothing. Bravo. Be a cunt.
But there has to be a mathematical explanation to that.
Why? Again, like I said, I'm not challenging observed reality. I'm not challenging math that's worked out and is functioning. I'm challenging what they're claiming is causing the math, what's causing the relationships. I'm saying there's a better answer. Duh. I mean, really, substantively, just like Einstein, I'm challenging causes, not effects. Einstein wasn't challenging effects, he was challenging causes.
Why does, if matter as it speeds up becomes more stretched out and disintegrated, surely parts of it would become it would be unevenly disintegrated, and it would start to dismantle at lower speeds.
Yeah, why? At lower speeds, it's at the speed of light differential, as I've pointed out. The Planck constant is a tiny amount of speed. It takes a tiny percentage of the photons to be moving in a direction to be going 10 miles an hour or 50 miles an hour. It would take a tiny percentage of a change in movement. You know, that's just a fact, okay? It doesn't take much energy. That's what we know that, in a sense, that the amount of energy in the atom is gigantic compared to the amount of energy displayed in its motion, right? The amount of energy in the atoms of a car is preposterously gigantic compared to the amount of energy expelled in moving the car, even though the car weighs 10 tons or whatever it could weigh, you know, Humvee or something. It's still a tiny fraction of the amount of energy in the whole. So I'm saying it's a tiny percentage of the fish that have to actually change their direction.
And how is it the relation? The relation follows Einstein's, because it's not a linear relation. The faster you go, it doesn't linearly get harder and harder to push an object. It's only as you get extremely close to the velocity of light that...
Yeah, well, that's Einstein's thing, okay? None of that can be proven anyway, because that's all theoretical, because we have no examples of these things actually working in the real world. You can't move matter the speed of light, so we don't get to observe it and watch what happens to it. So that's just theoretical. I would contend that there may be mechanisms where, obviously, if you're at first just changing orbits of electrons, maybe you change the dynamics substantially when you have to start changing the protons and the neutrons. You know, these are all different expenses that you'll have to, different prices you'd pay depending on how much speed you acquire, how much you're going to affect different arrangements. So yes, electrons are an arrangement, protons, neutrons, they're all different arrangements, and different arrangements are going to be degraded to more or less of an extent by different amounts of acceleration. I would certainly say that's possible. But I can't tell you any of that because I can't do any experiments.
This thing suddenly takes effect. Gary likes to begin all, you know, place major emphasis upon E equals mc squared. And it's a very important formula, but it's very easily derived from Einstein's principles and very... from special relativity.
Well, I think it's idiotic to derive it that way. I just think the idea that we already understood it to be a fact that the structure of matter could be converted, and in that conversion process you would release photons. You know, it is sort of in there, but I'm just saying the idea that there's some mechanism, like photons go in and somehow they're held in a suitcase or something by the matter. The matter holds the photons in a suitcase. You know, it puts them in a box on the shelf. That's the theory you're defending. That somehow matter means you have a mechanism where you take in energy and you store it somewhere. Okay, but then when you're disintegrating,